This is June 2016, paper 2. This is question number 5. This man is using a wheelbarrow to carry some logs. He pushes with a horizontal force of 140 newtons to a distance of 39 meters, and this is a relationship between work done, force and distance. It's work done equals force times distance. Correct symbols are fine. Normally you could just write it out. You have the words in the question, so work done equals force times distance, but the symbols are okay, and you could also use S instead of distance here, and S of course is displacement. Now we're going to calculate. So we've got 2 marks for this, going to show our calculations. The work done moving the wheelbarrow. We've already written out the equation, so it equals 140 times 39. Already got the units for us, so we just have to write down 5,500 joules of energy. State how much energy is transferred to the wheelbarrow. Well, if that's the amount of work that was done, that's the amount of energy. Look, same symbol. Work done is just energy transferred. So I can just write down exactly the same thing here. It's always going to be easy. Just state for 1 mark. Now the next thing is moment. So the man stops and holds the wheelbarrow horizontal. So all the forces are balanced here because it's not moving. The man exerts a total force upwards of F, and the weight is 470 newtons. Mark X on the diagram to indicate the center of gravity of the loaded wheelbarrow. Well, if this is the weight where the weight is acting, the center of gravity should be somewhere above that line. So it should be in line with the weight arrow and vertically between the tail of the arrow and the top of the wheelbarrow. Somewhere along this line would have been absolutely fine. State the equation linking moment, force and perpendicular distance. You've got M equals F times D. Again, symbols are okay, but you could also write moment equals force times distance. Now we're going to calculate F. So we're going to use the principle of moments. So we're going to write that down first to show that we know it, because this is a 4 marks, so it's well worth writing out. So we're going to say clockwise moments equals anti-clockwise. So we're showing them that we're using the principle of moments in order to work this out. So now we're going to identify which are the clockwise moments. So which of these two moves it round in this direction, the clockwise direction? So it is definitely the weight, so that's 470 newtons. Now, where is the pivot? Well, if you move this up and down, at what point around is it going to move? It's going to be this one. So it's 0.6 meters away from that pivot. And then we've got the anti-clockwise moving around this way. Anti-clockwise is our F. How far is that away? It's 1.4. So now we can work out this side, and then we can say 470 times 0.6 is 282 equals 1.4 F. Therefore, F equals 282 divided by 1.4, which equals 200 newtons. And notice 1, 2, 3, 4. I've got 4 lines because I want to show that I can get that 4 marks. And that's question number 5.